Good evening, guys. Am I audible?
Yes, sir.
Okay. So get started. So what was the topic we were seeing yesterday? So we started linear programming and we were seeing some concepts, right? What the first exercise, I think it is over. Did you guys get a chance to try those problems?
You can solve a sample problem from the exercise, sir.
Okay, that's fine. But at least did you try? Did you find any difficulty? Were you able to manage, Joe? Somebody's mic is on. One minute, my device is slow actually. 1 minute. Okay. So what was I asking? Yeah, is there any difficulty that you guys faced? I think it was easy, right? At least for this, you can answer that. You didn't try at all, huh? Okay, that's what I understand. You guys have not tried, no problem. You try it. It's a simple chapter only. So we will see the different types of linear programming problems. See, I'm not sure that these are there or not, because last year also we had the same syllabus, but some people told it was there and some told it was not there. But I'm teaching you on a safer side only, because last year exam didn't happen and we don't have papers. Okay. So let's try to understand this concept. So these are all statement problems, a few important linear programming problems. Okay, before that, is there any other doubt that you have from yesterday's discussion? Is there anything you didn't understand yesterday, which was not clear?
No, sir.
Okay. Okay. So the next set of linear programming problems that we'll see is manufacturing problems, then diet problems and transportation problems. So what are these manufacturing problems? If you read it, you will understand what are they trying to say. So in these kind of problems, we'll determine the number of units of different products which should be produced and sold by a firm when each product requires a fixed manpower, machine hours, labor hour per unit of product, warehouse space per unit of product, etc. in order to make maximum profit. So manufacturing, obviously, you know, right? You buy a mobile phone, somebody has to manufacture it. For manufacturing, what you need a fixed manpower. There are certain machines supposed to run. Then there are certain labor hours per unit of product. Then you will have the warehouse space, like how much storage you can have. All these things are taken into consideration. And the main objective of any business is to make the maximum profit. Right. Second, diet problems. So in these problems, we determine the amount of different kinds of constituents or nutrients which should be included in diet so as to minimize the cost of the desired diet such that it contains a certain minimum amount of each of the constituent or nutrients. So this has something to do with our diet. Sir, and the third is transport. Please,
sir, are you sharing your screen, sir?
Oh, I didn't share it. Sorry. I thought I was sharing it. Okay. So there are three kinds I told you, right? One is manufacturing, one is diet-based, and the third is transportation. Name itself is suggesting. Transportation means. So we determine the transportation schedule in order to find the cheapest way of transporting a product from plants or factories situated at different locations to different markets. Here also, you will try to minimize the cost. Transportation means you are paying for the transportation, means you will try to minimize the cost. You see, for example, if I have to give you a real-time example, let's say you have to send your books to your cousin. Okay, let's say you have completed your 11th standard, you want to share all those books to your cousin who is in another part of the state. Okay, then what will you do? You look for a courier service. In the courier service, what is it you look for? You'll obviously look for a courier service who do a good job at a lower cost, right? So you will try to minimize the cost and you will go with them. So that is something similar to the transportation problems. Okay. So let's get started. Only thing is you will be given a statement unlike the previous exercise and you need to form those equations to solve the question. So first, shall we get started, guys? Okay. So there is a dietitian who wishes to mix two types of foods in such a way that vitamin contents of the mixture contain at least 8 units of vitamin A and 10 units of vitamin C. Okay. Food 1 contains 2 units per kilogram. Okay. Food 1 consists of 2 units per kilogram of vitamin A and 1 unit per kilogram of vitamin C. So what are the two types of vitamins the dietitian is planning to mix? Vitamin A and vitamin C, out of which you have 8 units of vitamin A and 10 units of vitamin C. We don't know what those units are. So food 1, there is one food that contains 2 units per kilogram. So if there is a kilogram of that food available, in that there is 2 units of vitamin A available and 1 unit of vitamin C that is available. Similarly, there is another food which contains 1 unit per kilogram. In 1 kilogram, you have 1 unit of vitamin A and 2 units of vitamin C. So it costs rupees 50 per kilogram to purchase food 1 and rupees 70 per kilogram to purchase food 2. Formulate this problem as linear programming problem to minimize the cost of such a mix. Okay. So when the dietitian is planning to do this, he or she, when they are trying to buy the raw materials, and during the process of preparation, it is observed that to prepare food 1 of 1 kilogram, how much are they supposed to spend? 50 rupees. And to prepare the food 2, they need to, the cost is 70 rupees per kilogram. Okay. So how to do this? We need to introduce certain variables. Okay. So let the mixture contain, so there are two foods type, right? So let the mixture contain X kilogram of food 1 and Y kilogram of food 2. So obviously, what can you say? X will be greater than or equal to 0, Y will be greater than or equal to 0. Means you might buy food 1, you might not buy food 1 also. So we can make the following data. So what are all the resources that are available in that case? You have vitamin A in units per kilogram, vitamin C in units per kilogram, and the cost in rupees per kilogram. So food 1 contains X. So here mixture contains X kilogram of food 1. So how many kilograms are there? So it is 2 units per kilogram. Food 1 contains 2 units per kilogram of vitamin A and 1 unit per kilogram of vitamin C. And what is the requirement? The requirement is 8 units. So resources, food, and the requirement. Okay. What about vitamin C? Vitamin C. So vitamin C is 1 unit per kilogram in food 1 and 2 units per kilogram in food 2. And the requirements is 10 units. Okay. And the cost is 50 and 70. Are you guys able to understand how this table is formed? So this is a similar kind of table you need to prepare for all kind of diet-based problems. Okay. Shall I proceed, guys?
Yes.
So this is the available data. But from the given data, what is that we are expected to do? We need to formulate and solve the problem using the linear inequalities. Right. So what can you say? 2x plus y, right? Since the mixture must contain at least, this is the keyword, at least means minimum. At most means maximum. So minimum means greater than or equal to. Maximum means less than or equal to. I hope you know this, guys. Right? Wherever you see the word minimum, it is greater than or equal to. Wherever you see the word maximum, it is less than or equal to. Okay. So 2 into x plus 1 into y should be greater than or equal to 8. Similarly, 1 into x plus 2 into y should be greater than or equal to 10. Okay. Now, what about the cost? So what is it you need to minimize? You need to minimize the cost. That cost is written as a objective function. So what is going to be the objective function, guys? The total cost Z of purchasing x kilogram of food 1 and y kilogram of food 2 is given as Z is equal to 50x plus 70y. You need to minimize this cost. Right? So did you get the constraints? After this, will you be able to solve? So 2x plus y greater than or equal to 8, x plus 2y greater than or equal to 10, x comma y greater than or equal to 0. So you will draw the graph, and from the graph, you will be able to find the minimum value. But this problem you need not solve because it is an unbounded. Okay, unbounded, we need not worry about it. Guys, am I clear? My concern is, did you understand how to frame these equations?
So I have one doubt, sir.
Tell me.
So in food 1, it was given 2 units vitamin and 1 unit vitamin C, sir. How did we fill the table, sir? Like column wise or row wise?
You filled it column wise. No, row wise actually. You filled it row wise. See, I'll repeat this part alone. See. So the table for any diet-based problem, you need to have this table and whatever is the constraint. Here it is, obviously for diet-based problem, it is going to be food only, food 1 and 2. So here, what we are saying, the mixture should contain at least 8 units of vitamin A and 10 units of vitamin B. So what we can do is, you can take x kilogram of food 1 and y kilogram of food 2. So x and y are the variables allotted to whom the amount of kilograms of food that you need. Okay, in which the vitamin A in the units per kilogram. So food 1 should contain how much? Food 1 contains 2 units per kilogram and 2 units per kilogram of vitamin A, and the food 2 contains 1 unit per kilogram of vitamin B. Vitamin A, sorry. So you're first filling it row wise. Then you're going to concentrating on vitamin C. So how much does the food 1 contain? It contains 1 unit per kilogram of vitamin C, and 2 units per kilogram of vitamin C. Are you able to understand? So, but what is the basic requirement? You need 8 units and 10 units. The minimum is 8 and 10.
Understood.
Are you able to understand, Rohan? Yeah?
Yes, understood.
Yeah. So next, example 7, allocation problem. So a cooperative society of farmers has 50 hectares of land to grow 2 crops X and Y. The profit from the crops X and Y per hectare are estimated as rupees 10,500 and 9,000 respectively. To control weeds, a liquid herbicide has to be used for crops X and Y at rates of 20 liters and 10 liters per hectare. Further, no more than 8,000 liters of herbicide should be used in order to protect fish and wildlife using a pond which collects drainage from this land. How much land should be allocated to each crop so as to maximize the total profit of the society? So try to read it like a story. So in the story, what are they trying to say? There is a cooperative society, and that society is related to the farmers. And how much is the total land that they have? They have 50 hectares of land, and they want to grow only 2 crops. What are the 2 crops? They are X and Y. Okay. So the profit from the crop X per hectare is 10,500. Okay, like that, how many hectares that crop is there? those many times it will get multiplied. See, for 1 hectare, it is 10,500. Let's say there are 10 hectares of it. It will be 10,500 into 10. Similarly, for Y per hectare is observed to be 9,000. Is it clear till this step? Right? So this is the outline structure that they have in their mind. Now what they want to control the weeds using a liquid herbicide which has to be used for crops X and Y at a rate of 20 liters and 10 liters per hectare. Okay. Further, no more than 8,000 liters of herbicide should be used in order to protect fish and wildlife using pond which collects drainage from this land. How much land should be allocated to each crop so as to maximize the profit of the society? So there are certain constraints that are there. Okay. So here, what is the major controlling factor? What is that we need to find? We need to find how much is the amount of land that is to be allocated to each crop. Okay. Let X hectare of land be allocated to crop X and Y hectare of crop of land be allocated to crop Y. So first thing that is clear is X greater than or equal to 0, Y greater than or equal to 0. Obviously. Right. So profit per hectare is 10,500 for X and 9,000 for Y. So Z will be equal to how much? 10,500X and 9,000. Correct, Ada? This is the total profit and our job is to maximize this. So how will you do it? Tell me the other equations that you can form. So one thing that is clear, X hectare plus Y hectare should be less than or equal to the total available land. That will be the first equation. So this is the constraint related to the land. What are the other constraint that is related? Constraint means restriction. What is the other restriction you have? You need to use 20 liters per hectare and 10 liters per hectare for crop X and Y. So 20 liters into X for crop X plus 10 into Y should be less than or equal to the maximum you can use is 800. Should be less than or equal to. Guys, are you clear with this?
Yes,
So
sir.
one constraint to land and one constraint with respect to the herbicide. So when you plot this, you will definitely get. So one thing it is clear, guys. See, wherever you have this kind of thing less than or equal to and less than or equal to, at that point you will have a bounded graph. Wherever you have greater than or equal to, you will always have an unbounded graph. That's it. Okay, X plus Y less than or equal to 50, 2X plus 10Y less than or equal to 800. When you plot the graph and solve it, you will be able to find the maximum profit. It means 30 units of land should be given for X and 20 units should be given for Y. Okay. So what I'm trying to say is from here onwards, everything, if these equations are given, you guys know how to solve it. So the only challenging factor with respect to these kind of problems is framing these equations based on the constraint.
I have a doubt here. Constraint.
Tell me.
How did we say X plus Y should be less than or equal to 50? Sir? Should be equal to 50. Right?
It need not be equal to, right? It need not be equal to. Means sometimes what will happen is to maximize the profit, maybe you leave some land free also. Who knows? You need not do
In
it.
the question they mentioned all of the 50 acres.
Where did they say? How much land should be allocated to each crop? They didn't say everything should be used.
Okay, sir.
See, this is what we did with respect to that also, the chair and the table problem yesterday. You remember, he had 50,000 in hand, right? So the sum of the chair amount plus this thing is less than or equal to 50,000 means there might be a case where he doesn't want to spend also. See, this turns out to be a project where there is no profit at all, then obviously they will not even do it. I'm talking about a real-time thing. Here they are saying that there is a profit, right? So that is the reason why we are using this less than or equal to. Are you able to understand that?
Okay, sir, I understood.
Understood, right? Okay. So here, obviously, you will get a bounded graph. By looking at the equations, you can say less than or equal to, less than or equal to. So bounded graph, yes, you will be able to find the maximum profit. Correct? Guys, just give me 2 minutes time. I'll add some water. In the meanwhile, if you guys are clear with this, you can just read the next problem. Keep reading the next problem. I'll be back in 2 minutes. Yeah. So shall we see this problem? So this is based on manufacturing problem. So manufacturing, obviously, they will see maximum profit, right? So manufacturing company makes 2 models of A and B, 2 models A and B of a product. Let's say 2 mobile phones, okay? Okay. Each piece of model A requires 9 labor hours for fabricating and 1 labor hour for finishing. Similarly, each piece of model B requires 12 hours for fabricating and 3 labor hours for finishing. For fabricating and finishing, the maximum labor hours available are 180 and 30. Okay. The company makes a profit of rupees 8,000 on each piece of model A and rupees 12,000 on each piece of model B. How many pieces of model A and model B should be manufactured per week to realize a maximum profit? What is the maximum profit that is possible per week? Okay. Did you guys understand the question? How many pieces of model A and model B should be manufactured per week to realize maximum profit? So the company makes a profit of how much? 8,000 on each piece of model A and 12,000 on each piece of model B. So let the number of pieces be X and Y respectively, because that is the thing we need to find. So suppose X is the number of pieces of model A and Y is the number of pieces of model B. So what is going to be the total profit, guys? What is going to be the objective equation? It will be 8,000 on X and 12,000 on Y. So Z is fixed. Okay. So we need to maximize this. Correct, Ada? So subjected to, what are all the restrictions you have? So you need 9 labor hours, right, for X and 12 labor hours per Y. That's what they're saying. No? 9 labor hours for manufacturing and 1 labor, sorry, and 12 labor hours for B. Okay. And 12 labor hours for B such that this is for fabricating, guys. So for fabricating, the maximum labor hours are 180. What do you mean by maximum? Less than or equal to 180. So this is the fabricating constraint. Is there anyone having a doubt in this? So 9x plus 12y is less than or equal to 180. Now, what will be the finishing constraint? You guys frame the equation and tell me. X plus
3y.
X plus 3y less than
Less
or
than or
equal to
equal to 30.
Okay, this is the finishing constant. Now, x is greater than or equal to 0, number of models of this thing, and y is greater than or equal to 0. Solve this, we'll get the answer. And here also you will get a bounded graph because you have less than or equal to less than or equal to. You will get this, you can maximize the profit. Guys, am I clear?
Yes, sir.
Yes, sir.
So this is how you frame equations. The last type of problem that we are going to see is transportation. For transportation also we saw, right? We didn't see transportation. Okay. So will you guys try to frame the equation for this problem alone? I'll give you 2 minutes time. Try to frame the equations. Actually, you need not do the direct problem. Actually, don't waste your time because direct problems will always be about unbounded regions. So you need not do it. That's it. There is nothing much. Okay, you can try out this problem because there's with the bounded thing. So read this question, try to do it. A dietitian has to develop a special diet using 2 foods P and Q. Each packet containing 30 grams of food P contains 12 units of calcium, 4 units of iron, and 6 units of cholesterol, and 6 units of vitamin A. Each packet of the same quantity of food Q contains 3 units of calcium, 20 units of iron, 4 units of cholesterol, and 3 units of vitamin A. The diet requires at least 240 units of calcium, 460 units of iron, and at most 300 units of cholesterol. How many packets of each food should be used to minimize the amount of vitamin A in the diet?
So how to find Z in this, sir?
How to
Find Z in this.
They're asking what is the minimum amount of vitamin A. So you have to find the constraint for, you have to find the, sorry, you have to minimize the amount of A. Okay. So the question is about how many packets of each food. Okay. So since how many packets, for the packet, you will get the variables X and Y. Let X and Y be the number of packets of food P and food Q respectively. Obviously, X is going to be greater than or equal to 0. Y is going to be greater than or equal to 0. So mathematical formulation of the given problem is as follows. What are they saying? What is the minimum? You need to minimize the amount of vitamin A in the diet. Amount means here it is not money. The content. You need to minimize the amount of vitamin A in the diet. Okay. So how much is the amount of vitamin A that is available in food A, in food P? 6 units of vitamin A here. And here it is 3 units of vitamin A. So 6 into X number of packets plus 3 into Y number of packets will be the objective function. Rohan, am I clear?
Yes, sir, not clear.
Okay. Now other constraints is on the other items, right? So 12 units of calcium, so 12 units of calcium in X plus 3 units of calcium in Y should be at least not greater than or equal to. So greater than or equal to 240. Okay. Similarly, 6 units, 6x plus 4.
Yes, sir.
4x plus 20y should be greater than or equal to iron how much? 460.
Yes, sir.
Then what about cholesterol? 6x plus
4y.
Should be at least than other. And at most. So less than or equal to 300. So wherever you have a combination of like this, these things, then you will have a bounded graph. So here it is a bounded graph and you can minimize it, right? Other things you guys know how to solve it. Correct? So that's it, guys. Actually, we'll do a transportation problem. So 100. Wait, let me check if it's there. Okay, it's better it's not needed. These are all the things that you need. That's it. So since now you know how to frame the equations, I suggest you guys to try out this exercise problems. Okay, if there is any doubt, do reach out to me. Okay. Any other doubt, guys? Any other doubt from today's class?
No, sir.
No, sir.
I hope that you guys are clear. So I suggest you guys to practice it once. Try out few problems, and if there are any doubts, do reach out. That's it. So with this, I can say that term 1 portions are over. Okay. Now you have only tests and all those things. So prepare well for the tests. For the next 2 weeks, what I will be doing is I'll be solving some assignments. I'll give you some assignments and we'll solve problems from them.
Okay. I have a doubt, sir, actually.
Please tell.
Sir, for finding corner point for Z, sir, is there any way to find it without the graph?
Which one?
The Z corner point. We have to substitute in Z value.
No, you can't do it without graph. You will not get the corner points. No. See, the main objective of graph, I told you yesterday, when you're solving
from the other points, sir, is it possible to get it from the other points based on the other corner points we get from the
based
constraints?
on other points? I didn't understand.
So, and yesterday's example we found some corner points. From 3 other corner points, we can find the Z1, right?
Yeah, that is what we do. Everywhere we do. We get 4 corner points whenever it is a bounded graph. From all the 4 corner points, we keep substituting. Right?
We can't find it like from 0, 50, 50, 0, and 0, 0.
We have done it, 0, 50. But see, 0, 50 will give you a value. Try to understand, Rohan. It will give you a value. But out of the 4 corner points, which one will give you least synergy? You can get it only through graph here.
Okay, sir.
Okay. See, actually, to be honest, you need not draw the graph. I understand what you're asking. I understand what you need not draw the graph actually. You will treat them as, so you mean to say you will treat them as equality, solve them. Correct?
Yes, sir. Yes, sir.
You take them as equality and solve them, and you will try to substitute the different points and see. But see, if you get a graph which contains the origin, yes, you're on a safer side. But what if you get a graph like this which does not contain an origin?
Okay, sir.
You will get stuck there, no?
Yes, sir.
Yeah. So that's the thing. I think graph is not a big deal, right? I think it's going to take less amount of time only.
Yes, sir.
You're drawing this graph only to check the shaded region. Anyways, see now, if I'm not wrong, since it is objective, you're only going to have a rough graph that you're going to draw. So just draw it and find out the region. Based on that, you substitute.
Okay, sir.
Okay. Yeah. That's it. So the remaining problems, I want you guys to try it. Any doubt, reach out. That's it, guys. Okay. So if there are no other doubts, we can wind up this session. Shall we wind up? Yeah.
Yes, sir.
Yes,
No
sir.
doubt, sir.
No doubt, sir.
Oh. Okay. We'll wind up this.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.